Good morning, good afternoon, good evening, depending on which time you are currently in. Welcome to an introduction to Ricoh 3D with a virtual tour of our facility. My name is Mark Dickin and I head up the additive manufacturing team here at Ricoh. So we have a presentation and video to share to you, and we would welcome your questions throughout. Please submit your questions via the Q&A function, and we will be pleased to answer as many as we can during the Q&A session at the end of the presentation. If your question is confidential, our contact details will be shared at the end. And if you think of anything afterwards, please feel free to email us and we'll gladly answer your query. Just for your reference, the webinar will be recorded and shared with you over the next few days. So, as I mentioned, I am Mark Dickin. I'm the engineering manager for additive manufacturing and our injection moulding at Ricoh. We're really missing the interaction with our customers on site and are conscious that many of you have never visited us. So we thought we'd use this opportunity to bring our facilities to you virtually and show that although we're a service bureau, technical expertise, engineering innovation and manufacturing knowledge are central to the service that we provide. Presenting today will be Enrico, who is our material specialist, and Rich, who specialises in design. Just quickly, I'll go through some of the areas we'll be covering today. We'll start with an introduction to Ricoh and our 3D printing business before moving on to a virtual tour of our state-of-the-art smart factory and the technologies on offer. Enrico will then take you through a closer look at our materials and some use case applications. We pride ourselves on offering a true end-to-end service here. So we'll finish up by looking at some of the other services that we're able to offer in application development and customized manufacturing before ending on the Q&A session. I will now hand you over to my trusty colleague Rich to start the presentation.
Thank you, Mark. So I'm going to start with who we are, who is Ricoh. To start with, and for those of you who are not familiar with Ricoh, we're a large Japanese company with headquarters in Tokyo. We have a global presence as we operate in more than 200 countries and we have nearly 100,000 employees. The company was founded in 1936, originally to manufacture and sell sanitized paper. So we have more than 80 years of experience in manufacturing. And since its foundation, the company has very much evolved. And today our mission is to help businesses transform their processes to become more efficient, productive, and profitable by empowering their digital workplaces and digital operations. Innovation and quality are at the heart of what we do, and as you can see, we hold more than 50,000 patents worldwide, and our operations comply with several quality standards. As an organisation, we all work to the same values which bind us together as one global family. We have a long history of innovation. Most people know Ricoh for our office printers. However, our product portfolio and capabilities extend much further than that. We do have a wide range of commercial and industrial printers as well as inkjet heads, but as you can see on this slide, we have a diverse portfolio that goes beyond printing, from cameras to data management solutions, from interactive whiteboards to bioprinting technology. And of course, last but not least, 3D printing sits in our industrial printing line of business. Initially, we've entered this market by supplying our printing heads to 3D printer manufacturers, but also by using the technology within our group on our own products and manufacturing operations. We launched our selective laser sintering printer and our polypropylene material to the market in 2015, but since last year, we've refocused our strategy in Europe on offering a range of additive manufacturing services, making 3D printing accessible and taking an honest approach to its role as a manufacturing tool. Ricoh 3D is located at our factory based in Telford in the centre of the UK. We have an engineering function within group supporting our core businesses operations at our marketplace factory. At Ricoh in Telford, we have our own independent businesses such as our Inkjet Technology Centre and our Additive Manufacturing Centre of Excellence. At this factory, we have a history of a customer-centric approach and co-creation, developing solutions with customers. Our core business operation is the manufacture of toner products. Toner is of course a fine powder which synergies with additive manufacturing and our own powder bed system. So we're a manufacturer at heart. This is where our specialities lie, and we are geared up for mass production. We have used 3D printing for many years in the development of our own products and manufacturing operations, which puts us in a good position to fully understand the benefits of where additive manufacturing sits. We apply a holistic approach to manufacturing and only use 3D printing where there is a benefit to do so. We also look at the complete end-to-end supply of a product to see where the gains in using 3D printing can be made. There is a myth about additive manufacturing parts being significantly more expensive than traditional parts, which, when only comparing part for part price, can often be true. But if you consider the other benefits to the supply chain, the cost can be offset, or better still, when a part is designed specifically to be manufactured by the technology. Here we have a few examples of where we have used 3D printing within our organisation. On the left, we have a dynamic printer envelope feed. The images show the transition from an expensive CNC manufactured device to a 3D printed alternative, which reduces lead time from 4 weeks to 9 hours and allows this low demand solution to be printed on demand, which is of course more cost effective. In the centre, we have a Ricoh production printer showing where we have integrated 3D technology into our core printer production, leading to improved functionality and reduced production costs. And at the end, on the right hand side, we have a toner bottle production where we have used 3D printing in the manufacture of jigs and fixtures, maximising efficiency of a conveyor line with a 50% cost saving for a full set of interchangeable bottle pucks. The power of 3D printing is also being used in the global fight against Alzheimer's disease. We're really proud to be part of this initiative, which today is a powerful educational tool for Alzheimer's research in their roadshows across the country. Ricoh is an organisation with a heart, and this is really demonstrated in partnerships like this, where the whole organisation comes together as one to support this fantastic charity. I'd really encourage you to take a look at the moving campaign video featuring Simon Pegg if you get a chance. We are more than a printer, we are a partner, manufacturing parts and developing applications with our customers to drive innovation through hardware, material and software development. We take an innovative approach and offer a unique range of materials, and we apply our 80 years of manufacturing experience to transform processes and create robust manufacturing operations. Our aim is to make additive manufacturing a serious tool for mass production through application development and improve accessibility via our online platform and global reach. We have created a virtual tour of our 3D printing facility, which I will share with you now. Before I do so, I'd like to add that on a typical day, there will be a team of 12 people buzzing around the area, whether it be managing production or carrying out engineering tasks. We've decided not to include people in the video because of the current COVID-19 pandemic. So welcome to Ricoh UK Products Limited, the home of Ricoh 3D, and also core business operations such as toner bottling for the European market. As we enter our 3D printing facility, you'll notice some controls on the door. This is for health and safety, but also confidentiality reasons in line with ISO 27001. We now enter the main showroom, which we use to host events and seminars, of course, when we can. The whole production area was designed from scratch around the 3D printing production process. You'll notice designated production cells around the room, and this allows us to demonstrate tight material controls and contamination-free production, which is of course very important to industries such as the medical industry. We're now going to focus on some hardware, and in particular our selective laser sintering machine. We'll now move into one of the production cells, and you'll see the Ricoh printer. We have 5 of these printers at our facility. They have a large build volume, and they're able to manufacture single parts up to 0.5 meter cubed in size. They're able to process a range of materials from polypropylene, nylons, and it's also open parameter, which allows us to operate flexible production and change materials on those systems, which we will elaborate on later. You can also see the depowdering station to the left, which demonstrates a fully enclosed production cell and production control in one area. We'll now move across the showroom to our FDM printing production area. So FDM is fused deposition modelling, and in here you'll see a Stratasys Fortus 450 3D printer. It has a good range of engineering materials from ABSs, nylons and Ultem material, and this equipment and technology is really good for jigs and fixtures, and we use it a lot to support our on-site engineering activities. As we come out of that room there, you'll see our showcase full of customer parts as we go into our material testing lab. This area is very much Ricoh's area, and where material testing is conducted. You'll see a desktop SLS printer there on the left. We do melt flow analysis, DSC, powder rheometer as well. And we can also do 3D scanning and mechanical testing with the tensile tester. So back to the showcase, we have a good selection of parts from all industries, but particularly the automotive and medical sectors. And on top of the cabinet, you can see an ankle foot orthotic device that we developed with a local hospital. Hi Keith and the team from Orlau, I believe you've joined us today for this webinar. Some large parts there on the right hand side. So we specialise in the manufacture of large parts like vehicle bumpers, so have a VW bumper there and a car baby seat. Now we enter our 3D printing academy, and this is normally a hive of activity with customers learning about 3D printing with us. We now enter the production control room, which is the hub of our 3D printing operation. You'll notice the monitor on the wall where we monitor the production and status of all of our orders. We can also monitor the machines and their status at any time. We manage our back office production system using specialist software, and the PCs that you can see are where we create build files, again using specialist software. So we just focus on one of the machines there, that with a build file being created. In 2019, we enhanced our service offering and expanded our production area, which we will enter now. So this new area is all about pre and post production, and it's where we manage the depowdering of parts. We manage powders, the mixing of powders, which are then refreshed to put back into machines. In the corner, you can see an area where we bond parts together, such as the Volkswagen bumper that you saw earlier, and other large parts. And as we pan around, you'll see additional depowdering stations for the other equipment that we'll go and see shortly. As we move forward, you will see the latest Ricoh machine, which was delivered at the start of May this year. And this machine will be running a new exciting material, which is a Thermoset material, which we will be launching soon. As we pan to the left, you'll see an automated depowdering machine. This is where we've streamlined our production and automated from a manual process, which we will do where we can. And you can see HP's MultiJet Fusion post-processing station as well. We now move into another production area where there are machines. So as we move forward on the right hand side there, you can see a high temperature machine from Farsoon, which we run a nylon 6 material with glass beads. As we pan to the left, you'll see a red system, which is a high-speed sintering machine, which we use for R&D. And then you can see the HP MultiJet Fusion machine there, which we run a nylon 12 material on. Just focusing on there on the parameters of the Farsoon machine. In the room behind us, we have the final two Ricoh SLS systems. So one on the right is where we manufacture larger nylon 6 glass bead parts, and the machine on the left is used for multiple operations such as material testing and also production. The machine is open as it's being prepared for the next job. You'll notice that machines have camera monitoring tools on them, allowing us to monitor builds remotely and interrogate builds, allowing us to build our knowledge towards right first time manufacture. We're now going to move to another part of the factory, to our injection molding facility. So by magic, we will go through these doors and we end up at another area of our factory. This area supports our core business operations. We have a range of machines from 25 ton up to 650 ton, and we now offer injection molding services to our clients for mass production. We've been molding on site in Telford for over 30 years. Here we can see the process of one of our COVID-19 headbands being injection molded. And once the molding stage is completed, the parts are placed onto a conveyor system and boxed up, ready for final assembly elsewhere on our site. We're just focusing on that now. All of our molding machines have pick and place robot automation to remove parts from the mold, as well as inspect parts by placing them to cameras for part assurance. We also add QR coding to individual parts for identification and traceability throughout the production process. We're now going to zoom into one of these automation cells to take a closer look. That concludes the virtual tour of Ricoh 3D. As Mark mentioned, we are really missing our visitors to our facility, and we would welcome anybody that wants to come and visit us. You're welcome to come and visit at any time, so please get in touch and we can facilitate that. I'm now going to hand over to Enrico, who's going to dive a little deeper into what you've just seen.
Thank you, Rich. Thank you for this nice virtual tour. So, just to summarize the technology you have seen during the virtual tour, our technologies are very much focused around manufacturing of polymer end-use parts. So from an additive manufacturing point of view, we offer powder bed fusion and FDM technology with the possibility for our customer also to have access to our internal injection molding capabilities. But having said that, we are also committed to keep investing in the very latest technologies in order to keep our service offering up to date. So at our facility, as you have seen, we have 5 Ricoh SLS system, and this machine are set up and dedicated to specific material. And currently we offer our unique polypropylene, Nylon 6 glass beads, and we will soon be offering also Nylon 12 from this system. As you can see, this machine has a large build volume, allowing us to produce large parts or large volume of parts at once. And we do also have a high temperature fast-run SLS printer for smaller, more time-critical Nylon 6 glass bead parts. And as Rich mentioned during the virtual tour, all these systems are open parameter, meaning that we are not locked into specific material, but as new material are developed and becomes available for this type of process, we have the possibility to integrate them into our portfolio. Sorry, the issue in the slide has gone. Okay, everyone should see the next slide. So on top of the SLS printer, we also have an HP MultiJet Fusion system, which is MultiJet Fusion system, which at the moment runs Nylon 12. And we also have FDM technology, which offers a wide and different range of material compared to the powder bed fusion system. On the FDM machine, we offer the full range of materials available in the Stratasys portfolio on that machine, including Nylon 12 with carbon fiber and also Ultem material. We will discuss more in details about these different technologies, material, and also highlight some case studies in the next few slides. When it comes to injection molding, in our injection molding facilities that we have been using for our own internal production needs for over 30 years. We have 12 injection molding machines ranging from 25 up to 650 tons. So as you can see, we are very well placed to cater for both large and small parts and give us a very holistic approach to manufacturing. And a really nice example of how we have combined all those manufacturing capability is the production of the COVID-19 face shield. So as a lot of companies during the COVID-19 pandemic, we have been involved with the production of PPEs, in particular protective visors to help protect frontline workers. To be honest, I really think that this has been it has been great to see the response of the whole 3D printing community during these very challenging times. It shows that actually this community has a big heart, but also it's probably demonstrated to the world, the manufacturing world, that 3D printing is an agile and capable manufacturing technology for localized and quick turnaround production. And we also think, from our perspective, that this has given us the opportunity to demonstrate that additive manufacturing technologies are also complementary to conventional manufacturing technologies rather than in competition with them. So for more specifically for the production of the visor that we actually still producing at our facilities, we have used the SLS technology at the beginning of the project to quick design interaction in order to optimize the design of the headband based on the feedback that we were receiving from the frontline workers. And once we have completed the design optimization phase, we have also used the technology to produce thousands of visors per week in the first few weeks, whilst we were producing an injection molding tool. Because in fact, from the very beginning, we did realize that injection molding was the only technology able to cope with the volumes and the cost per part on the long term. So then after a few weeks of producing the visor using AM, we have then moved to injection molding using the same material that we were using for 3D printing and using our own internal capability both here in the UK but also in Japan to scale up production. And we are now able just here in the UK to produce up to 40,000 visors per week. And also using our strong local network of suppliers, we have been able to source all the additional components for the visors in order to develop a product that has been recognized as very comfortable by the user of the visor. So we go beyond printing. And in parallel to that, we've also been involved in the production of prototype parts to support the work done by the National Physical Lab here in the UK as well. And I think it's also worth mentioning that for the visors, a couple of weeks ago, we did receive the approval for the CE mark, which ensure customer that the visor we produce comply with the highest health, safety, and environmental protection standards. So now let's dig a little bit deeper into our material offering, and let's start with our unique polypropylene material, which we have been processing on our printers since 2015. So polypropylene is a commodity material that is very widely used for a wide range of application in traditional manufacturing processes. It is used across different sectors such as packaging, automotive, for industrial application, or for medical devices, for example. It's a lightweight material. It's very stable. It's very chemical resistant, and in particular, our material for selective laser sintering is also very flexible, fatigue resistant, as you can see on on the video on these slides. And those properties allow us to produce functional and durable living hinges, for example, and which are a lot more difficult or whether impossible to produce with other 3D printing materials currently available. And also, just to give you some numbers, we have done some fatigue tests on the material, and the material it's actually able to withstand up to 1 million cycles during fatigue tests. The material is also easy to recycle, much more easier to recycle than the Nylon 12, for example. So it's a material that is a lot more sustainable. Polypropylene parts printed on our machine are also very smooth, watertight, and are airtight up to 10 bar, straight out of the printer. So there is no need for any post-processing to achieve those properties. The material has also been approved for use with drinking water application, known as VRAS approval in the UK. So VRAS stands for Water Regulation Advisory Scheme. And also the material is also a very good choice for applications such as fluid management products, tubes, liquid container, and we do also support the medical application with this material. So now let's dive into some case study where customers have been benefiting from the properties of this material and the use of additive manufacturing. The first one is from a local hospital to us here in the UK, the Robert Jones and Agnes Hunt Orthopedic Hospital. Their orthopedic department was having issues for years with patients struggling when they needed to fit, adjust, and remove their ankle orthotic picture on the right hand side of this slide. And as you can see on that picture, an additional tool was required by the user, which they had to carry separately with them to compress and decompress the gas spring, which was quite annoying for the patients, especially those with restrictive movement. So the team at Orlau, they came up with a very clever solution and developed a lever hinge mechanism, which actually stays on the device and makes life easier for the patient. So originally, this was first manufactured through conventional machining and assembly. But after a discussion with our team, we have helped them redesign the part by leveraging some of the benefits of 3D printing, by consolidating the ball joint feature and removing the need for assembly. And also, polypropylene enables to create a cost-effective, lightweight finished product that is robust, flexible, and can also be customized according to the specific patient need. And the lever hinge mechanism that you can see in action in the video has been tested to over 3,000 cycles and has an estimated lifespan of more than 5 years. So actually now this device is in full production, and we are really proud to be able to help to make life easier for patients thanks to our additive manufacturing technologies and service. And it is also, I think, a really good example on how we've helped a customer in the end-to-end process from the design stage through prototyping up to serial production of the final component. Another sector that has largely benefited by using our polypropylene material is the automotive sector. And one particular example is the one from Toyota, which use our service to validate a number of exterior components for design, fit, and function. In this specific case, we were able to produce components, including the full bumper skirt for a Toyota Corolla in just a few days, enabling Toyota to dramatically speed up their validation process from several weeks down to just a few days, and that then save money compared to using a more conventional process. Also, by using a material that has properties that are equivalent to the one used for the final components, Toyota, they are able to use this component to run several performance and functional tests on the part, including, for example, wind tunnel testing. And so this is really speed up their development process for their test vehicle. And as you can see on the video, the part is quite large, but it has been produced in different subsections that we have then glued together before sending the parts out to the customer. So this is also something, the gluing and the joining process is something that we have optimized in-house for large component, and this is also enabling the customer to benefit from our continuous improvement methodology and working practices. And the third and last case study I want to touch on about polypropylene is the one with Hello. Hello is a customer that is based in Netherlands, so we work with customers across all Europe, and Hello is a market leader for plant care products such as plant pots, planters, or watering can, that you can also see in this video. They are a very innovative company, constantly adapting and improving the design of the product or developing new range of products, so that they need a way to validate their design by creating prototype very quickly and efficiently, and using where possible the same material used in the end product. And in this specific case, also Hello is leveraging the watertight properties of our polypropylene material, which can be achieved, as I mentioned before, straight from the printer without the need for extra post-processing. So the next material I would like to cover is PA6GB, which is a nylon 6 reinforced with glass beads. So this is a material that is an ideal choice for parts that needs to be stable, high temperature, and require very good mechanical properties. The material has a melting temperature around 210 degrees, and thanks to the glass beads included in the formulation, the parts printed with this material have also very good stiffness and very good dimensional stability at high temperature. The material has also got a very good resistance to fluids such as fuels, oils, greases, making it say the go-to and ideal solution for automotive application. So to illustrate some of the properties of this material, if we compare, for example, the tensile strength of nylon 6 glass beads against a glass-filled PA12, nylon 12, we can see that the value for nylon 6 glass bead is far greater than the one for nylon 12 glass beads. And also, as we can see on the graph, nylon 6 glass beads demonstrate a better retention of the mechanical properties as a function of the temperature, and in particular a high temperature. In this specific case, the component, the parts have been tested for aging in air at different temperature during 50 hours. As mentioned before, on top of the very good mechanical properties, the material also demonstrates a good resistance to automotive fluids, such as oils and fuels, for example. And the two graph here illustrate that the tensile modulus and the tensile strength of the material and how they are affected after aging at high temperature in different fluids. As you can see on the left-hand side, fluids such oil or biodiesel don't really affect much the mechanical properties of the components. However, as you can see on the right-hand side of each graph, polar solvent like ethanol 50, gasoline or glycols are far more aggressive towards polyamide 6. So this leads to a more limited retention of the mechanical properties after aging. So we do also offer Nylon 12 on the MultiJet Fusion technology from HP. So PA12 is a material that is really popular for powder bed fusion technology and offers a good trade-off between thermal resistance and mechanical properties. And the MultiJet Fusion technology, which works slightly differently compared to the SLS process, also allow us to produce parts with smaller features compared to what is possible with the SLS technology today. And as mentioned before, we are also looking at very soon be able to print PA12, so this material on our SLS system in order to be able to print larger parts or a lot more parts at once compared to the MultiJet Fusion technology. So to really summarize our offering in terms of materials for powder bed fusion technologies, I would say the polypropylene material is the ideal choice if you need good flexibility, fatigue resistance, and chemical resistance for your parts. For more demanding application, especially if you require resistance at high temperature or where high stiffness is required, say PA6GB is the go-to solution. And PA12 offers a good balance of the thermal and mechanical properties and also enable you to produce parts with finer details. So let's move now to a different technology as mentioned before. In addition to powder bed fusion processes, we do also offer the option to print parts using FDM, fused deposition modeling. So for FDM, as mentioned before, we have a Stratasys Fortus 450MC, and we are able to offer a wide range of material from more general purposes materials such as ABS and ASA up to high performance material like Ultem, which is a material that is very suitable for serial production and for highly demanding application, such as in the aerospace industry, for example. Another material that we and our customers also particularly like is the PA12 reinforced with carbon fibers. This is a very stiff and lightweight material with exceptional strength compared to other FDM materials. Thanks to these properties, it is an ideal choice for application again in the automotive or motorsport industry or for metal tooling replacement. And we also see that another area with a lot of potential for this material is for robot tooling, as the material enables to reduce the payload weight for this application compared, for example, to traditionally manufactured metal parts. But as mentioned at the very beginning of the presentation, we are a company that is very much driven by innovation, and we are always working to develop new materials or solutions that we can include in our portfolio and could help our customer expand the range of application where additive manufacturing can be used. So I would like to really touch on two of our latest innovation. The first one is one that we launched last year at Formel. Is a range of Thermoset materials that can be processed using the selective laser sintering process that traditionally use thermoplastic material. So we have developed this Thermoset material in partnership with Tiger Coatings, and as you can see in this video, compared to thermoplastic, this material has the main advantage of remaining in the solid state at high temperature, as they don't actually melt. So in this video, you can see in the middle the Thermoset material, and on the side two thermoplastic materials. So also the Thermoset material can be formulated with flame retardant properties. So when exposed to fire, they have a self-extinguish behavior. There is no polymer melt dropping, and they are also generating very low smokes. And this material also have good mechanical properties that can be easily customized based on the application requirement, and they can be printed without issues such as curling or warping that are typical of several thermoplastic polymers. So in terms of application, this material are a very good fit for application in the transportation industry, for example, or like railway, aerospace, e-mobility, that is a market that is really growing in the last few years, or also for electrical or electronic component. So at the moment, we are completing the final stage of the qualification of both the standard grade and the flame retardant version of this material on our printers, and we expect to be able to start offer parts printed with this material after the summer. And the second one, the second innovation I want to talk to you about, and this is really a first time we show this to people, is an exciting development that we've been working on in the last few months. Is a chemical smoothing process for our polypropylene material that we have developed in collaboration with the team at Additive Manufacturing Technologies up in Sheffield here in the UK. As I mentioned before, although our polypropylene material is very popular and we have some customer using it for serial production of end-use part, most of the application we still see for prototyping for form and fit. And like for other 3D printing material, one of the main blockers to enable the use of 3D printing for more application and for using the technology for the production of end-use part has always been the visual appearance of the parts being inferior to injection molded part, as generally parts coming out of the SLS process, although in the case of our polypropylene parts are relatively smooth, there is still this grainy texture, which is due to the fact that the process is a powder-based technology. So this great development actually solves this issue by allowing our polypropylene material to be smoothed to injection molding like quality, as you can see in the picture on the slide. And another great thing of this process is that only use green solvent. So it's a very sustainable solution, and also all type of geometries, even very complex ones that are probably typical and unique to additive manufacturing, can be smoothed consistently, which is another great thing compared to other technologies such as vibro smoothing that we are also offering in-house, but has got some limitation, because vibro smoothing, for example, can only smooth the outer surface of the parts. So, and another very interesting feature is that the process also improves the mechanical properties of the parts that we print. As you can see on the graph on the right-hand side of the slide, the elongational break for the part is significantly improved, up to 4 times the value of a smoothed part. But properties like the tensile strength or the tensile modulus are not really affected by the process. So we really believe that this is a huge step forward for us and our polypropylene materials. It opens up a completely new opportunity for its use in a wide range of end use and application, where a smooth surface is critical. Just think, for example, our application like for medical components, where parts needs to be in contact with the body. Those parts will need a smooth surface to for example, prevent the growth of microorganisms on the surface of the part. So we are really excited about this development, which with the teams at AMT we are now keen to develop further from this R&D stage, where we are now, to a commercially available fully automated solution that we want to integrate as part of our service. So if you're interested in knowing more about this process, we will jointly publish with AMT a white paper probably towards the end of this week, or in the next few days, and we will make sure to include also the link to access it in the email that will be sent out to share the recording of the webinar afterwards.
Thank you, Enrico. So in addition to print services, we also offer a range of technical services. Every customer is different, and we offer a tailored consultancy service with a customer-centric partnership approach. We're able to assist all customers, from beginners who want to find out more about 3D printing and where they can use it, to experienced experts who want to push the boundaries and drive innovation. We offer a range of post-processing solutions to complement our print services, and recognise that these are somewhat limited today, and we're committed to driving innovations in this area, as you have seen with the development with the AMT and based on what customers want and need. Today, these include part smoothing, joining and painting or dyeing of parts. We offer a full metrology service via contact and non-contact systems for part assurance. Here we have access to many systems, some of which are used within our core business, which include coordinate measurement machines, vision systems, and 3D scanners. And our material testing service is geared around innovations, developing new materials for new applications with customers who require something different to what is available on the market today.
Yes, just Richard said, as part of our service, so we are able to provide support in areas like material development, as we know that material choice for additive manufacturing is still quite limited, and need more material are required to unlock new applications. So thanks to our equipment that we have seen during the virtual tour, our knowledge and our strong network, we can work closely with our customer and also with material manufacturer, as we did, for example, with Tiger Coatings for the development of the Thermoset material to develop and really co-create new materials to expand the range of application for additive manufacturing, and also provide our customer with the best solution for the needs. So if the solution is not available now, we are really keen to develop that with you and together with you. And also, thanks to our internal capability, we are really able to take a material development project from the very early stage in the lab and bringing up to scale production on one of our printers.
We've recently launched a new website with live online quoting, allowing customers to see where 3D printing is cost effective for them. The website offers all of the materials and 3D technologies mentioned in today's presentation and is really simple to use. Our website also has some useful resources to assist you in the selection of materials and technology, with some best practices for design. So please have a look at what we can offer.
Thanks, Rich and Enrico. Absolutely brilliant. And thank you to everybody who have been listening. At the start, I mentioned that technical expertise, engineering innovation and manufacturing knowledge are in our DNA. Hopefully this presentation has demonstrated that. We're now going to move on to the Q&A section. Please note, though, that some questions will be answered via the Q&A panel, so please keep your eyes out for that. Right then, guys, here we go. Right, first question. Do you design material and manufacture it, or do you just manufacture designs given to you by a customer?
In terms of material, we are not a material manufacturer ourselves, so we really work in collaboration with material manufacturers. So we got a very good network and relationship with a lot of the main player in additive manufacturing. So it's really a co-creation process. But as I mentioned during the presentation, we are able, thanks to our equipment and knowledge, to really work with you with material manufacturer from the early stages, and really develop the material together and share knowledge. You got the knowledge on the printer, you got the material manufacturer has got knowledge in the chemistry. So it's really by combining our strength that we can develop the best solution.
Yeah, I think just to add to that as well, you know, we'll take in the application into mind, and we will choose the best material for the application. That's what we're all about.
Yeah.
Another question here: are the face shields available to purchase? And where can the guys get them from?
Yeah, the face shields are still available for purchase. All the details are on our website. You can actually buy them through the website as well, through the online portal. You'll have to sign up for that, but yeah, you can purchase through that. If not, we will include the details and get back to you on that question as well with a direct contact.
Next question here, we've got a Brexit one. I thought we'd get a Brexit one. How will you handle shipping of parts out after Brexit, shipping outside the UK, of course? I have here at Ricoh, at RPL in the UK, we manufacture core business components for Europe. So the majority of our product goes outside of the UK. And as a business, we have an extensive risk register looking at Brexit, etc. And we really don't feel that that our customers will see an impact whatsoever. We think initially there'll be chaos, but we don't think that after the first couple of weeks, we really don't see any major issues. So hopefully that will answer your question. A question regarding the Thermoset material. Does the Thermoset material have any UL 94 rating?
At the moment, we are really working with Tiger to qualify those materials. So it's really the end target is to test the material. We are aiming for a V0 UL 94. So really the highest level of fire retardant properties. So this is what we are aiming for. But as I mentioned during the presentation, the really nice feature of the Thermoset material that we, in partnership with Tiger, we can really customize the formulation. So we can adjust the level of performance depending on the requirement for the application.
Next question here, probably another one for you, Enrico. Do you guys do research in material properties in a scientific / academic point? Yeah,
we are involved in some projects with university. I don't really want to disclose what kind of project we are working on, but yes, we are involved in more also fundamental research as well, because we really want to understand the process and how we can improve it. Because as Mark was mentioning also at the beginning, we also looking on the long term to develop hardware, for example, from our colleagues in Japan. So all our learning are also useful for us here as a service bureau, but also from an R&D perspective long term for our colleagues in Japan.
Got a question in regards to the AMT technology, and how does that process interact with PP parts? What wall thickness can be achieved combined with the AMT process?
I don't really get the question. I think maybe I can try to answer by saying that we have done some testing on the dimensional stability of the parts, which will be available in the white paper. So the process seems to be quite stable in terms of respecting the dimensional stability of the parts. Obviously, is still at the R&D stage, so more work needs to be done when we will be upscaling the process. So in terms of also the minimum feature we can process. So I think it's still a learning process, but I can also, based on the experience that the team at AMT have with their process they've already developed for other material, I would say it's the ultimate goal is to really be sure that we can keep the dimensional stability of the parts.
Just to add to that as well, Enrico, obviously every print technology has a minimum feature size, whether it be MultiJet Fusion being 0.5 millimeter, our SLS printer being 0.8. The smoothing process developed by the AMT doesn't affect that, so those parts can still be successfully post-processed and maintain wall thickness and functionality. So there's no effect there. So the limitation there really is the wall thickness of the print technology itself.
We've got time for just one more question here, and I'd just like to ask: are the customers of your healthcare products mostly based in the UK? So, well, we can all answer that. We know we're working with customers within Europe and within the UK. So, our network extend across the European region.
Yeah. So we're not limiting our sort of customer base to UK. We're really working across Europe.
I think, guys, in the interest of time, we need to wrap up now. So I'd just like to say thank you for your time today. If there are any questions that we've not been able to cover, we'll make sure we follow up and would welcome you to get in touch with our team via our details here. Thank you all, and please keep safe.